In this question, we are given the masses of deuterium, proton and neutron. Okay, we are asked, right, the deuterium may disintegrate into a proton and neutron if it captures energy or releases energy. So which case will it be? So let's write out the equation. So we have a 2,1H turns into a 11P plus a 10N. So on the left hand side, right, we see that the mass is 2.0150 U. On the right hand side, right, these two sum together to give you 2.0, let me calculate, 183 U. Yeah, I hope I have done that right. So you can see, right, that the mass have increased. Okay, so if the mass have increased, right, so the right hand side has more mass, okay, then the left hand side is less mass. So right, by mass energy conservation, so we must put the energy on the side with less mass. Okay, conservation. So energy will appear like here. Okay, so this energy, right, is in this question implied to be a photon. Okay, comes in the shape of a photon, so it's just energy of a photon. Okay, we also don't need to say too much about it. If you need to calculate the frequency, then you need to know that this is equals to HF. Okay, so now, right, how large it is. So here we know that it must be captures of photon, so A and B will be out. Now, right, then you can go about calculating the mass difference. So the mass difference, right, so the E is equals to the mass difference times the C square. So mass difference is 2.0183 minus 2.0150, okay, times 3 times 10 to the power of 8 whole thing square. Okay, I forgot one step here, right? You see, this is always very common. We forgot to multiply in the atomic mass unit, which is 1.66 times 10 to the power of minus 27. So we calculate, we'll have 4.93 times 10 to the power of minus 13, and this divide by, so this is in terms of joule, we divide by 1.6 times 10 to the power of minus 13. So that gives you, right, this is MeV. So this conversion, right, is really common in nuclear physics. Okay, so you get around 3 MeV, and answer is D.